Good morning, ladies and gentlemen. Good afternoon, good evening, depending on wherever you are in the Americas, Africa, Europe, or Asia, Australia. I'm Wim Bankens, and I'm opening the second webinar in the series of CIB webinars on measuring urban sustainability.
But now you don't hear anything, of course.
As organized by the CIB W116 Student Forum. You will hear what 116 is later on. All the webinars are about urban sustainability and the measurement of this. This second webinar focuses on the energy issues in that context. The objective of this webinar. What we do is present and discuss state-of-the-art student projects from all over the world. We think that by doing so, we create a basis for exchange and cooperation between students with a similar interest. We also think that by asking questions by students from other countries or by experts, we help or we contribute to the validation of those projects, and we provide another stimulation to the respective students. I'm your moderator. I am Wim Bankens. I am the Secretary General of CIB, the International Council for Building Research and Innovation for Building Research and Innovation. The program for this second webinar. After my opening, and I have a few more technical remarks, there will be a short CIB introduction provided by Professor Andy van der Dobbelsteen about the CIB Commission 116 on smart and sustainable built environments. The commission that's the house for the student forum that organized all of this. Then we have an expert keynote presentation. It happens that also is provided by Andy. Then we have three student presentations, respectively by Umberto Berardi, Electra Columpi, and Nico Tilly. After each presentation, Andy, as the expert in the area, will ask them one or two questions. At the end, we will have an open question and answer session, dealing with the questions by the attendees, and that will be moderated by Laura Klerenkoper. Some logistical remarks. The CIB Secretariat, represented by Ton Heijblom here, is the technical host. The introduction, the keynote presentation, and the three student presentations will be recorded. We will make those recordings available after having edited them a bit via the CIB website. I'll talk about how later. Questions by the attendees are to be presented via the WebEx chat box facility. I'll talk about that in a minute. And after the webinar, we will provide a summary report with links to all the recordings, to all the attendees or all who registered, and you can forward that to whoever you want. How do you as attendee ask questions? You have to submit them via the so-called WebEx chat facility. If you are in the open full screen mode, when someone gives a presentation and you select to view that in the full screen mode, you see in the middle top of your screen something like a green bar that says viewing presentation of so and so. If you move your cursor over that green bar, a small menu will open. If you dare click on chat, a chat box will open. That chat box with this signal, symbol, allows you to type a question. You have to select someone to send it to, and you will have to select Laura Klerenkoper from this top-down, pull-down menu. The moment you push your return button on your computer board, the question will be sent, and you will see it in the box above that. Laura Klerenkoper will collect all the questions and at the end moderate a 10 to 15 minutes open question and answer session. If you do not look at a presentation in the full screen mode, but you look at that in the page that we call the WebEx Meeting Center, the one you see where you log in, with on the left a small screen with the presentation, at the right bottom corner you see the chat box already. And you do the same thing. So that's questions and answers. A quick introduction of Professor Dr. Engineer in Dutch, Andy van der Dobbelsteen. and he is from the Delft University of Technology here in the Netherlands. He's also the coordinator of the CIB Commission W116 on smart and sustainable built environments. He will present that commission briefly, and after that do his keynote presentation, which is his broad view on urban sustainability with the focus on the energy issues. Andy, may I invite you to do your first small CIB introduction?
Yes, Wim, thank you very much. I'll share my desktop, see if it works, and then do this. There you go. Okay, thanks Wim for your kind introduction. This is Andy van der Dolsteen from Delft in the Netherlands. So it's past 2 o'clock in the afternoon here. Curious how late it is with most of our attendees at the moment. But to give you a brief introduction first before I do my keynote speech, I will get you through a little bit of introduction on W116 and also a bit of introduction to the energy storyline. First, CIB Working Commission 116 is, I think, one of the most popular working commissions within CIB. If you look at the papers, for instance, submitted to one of the conferences soon, the CIB World Building Conference. Our goals are actually to promote research, application and education in the field of integrated development of smart and sustainable built environments. So it's a very broad, integrative topic that we cover. And of course we want to facilitate networking across the globe, dissemination of information and the technology transfer to businesses and industry. So the connection between academia and businesses is one of the main parts also. Our team consists of joint coordinators, Professor Jay Yang from QUT in Brisbane and myself. And we have a, hardcore team of regional coordinators. For instance, Vanessa Gomez, Ilke Audi-Gazelle, Jeremy Gibbett, Nori Yoko, and Frank Schultman, who are closely involved in all the activities and who basically consecutively organize events in their region. Now, the activities we have are, for instance, we have our own conference series, the SASB series. We just had one, a very nice one in Sao Paulo, Brazil. And the next one will be in the USA. I don't know the exact city yet, but Ilke Audi-Gazelle is going to organize that. Then there will be, that we also have sessions specifically focused on smart and sustainable built environments on the different CIB World Building Conferences and also Sustainable Building, which is also a CIB conference. And the next one will be next year in Brisbane in May. There were about 100 papers submitted in our theme, so there's enough to do for us for reviewing and also to present there. Important to know also, we have a journal of smart and sustainable built environments, which was founded and also edited by Professor Jay Yang. It has only started this year with the first edition in June, but it's already a very popular topic and for journal papers. So if you're interested, there's a link over there, and I guess CIB will provide my presentation later on, so you can find that link. And then, of course, there's the CIB W116 Student Forum, which involves all types of students from university across the world, which within CIB is typical because most student chapters are related to countries or universities. In our case, we are international. That's why this webinar series is very practical for us also. And thinking about these future engineers and designers and planners, I think we have to look a little bit ahead to understand the energy problem. Sorry, the wrong one. This future will hold many constraints that we didn't have in the past. So it's quite important to understand that we have to deal with climate change. So we have to be prepared for extreme weather events, scarcity of resources. So we have to use materials from the circular economy, and there's depletion of fossil fuels, which urges us to become independent from fossil fuels. So energy neutrality becomes a real goal. To start to understand the energy statistics, I think everyone in each country should understand what the exact figures are for heating, cooling, electricity, and also for mobility. These are the figures typically for the Netherlands, so a Dutch household, which typically is about 2.2 people in a household. Here you see that in terms of megawatt hours, we use about 31 megawatt hours per household, just for domestic purposes and travel. Now in the future, when we don't have any natural gas anymore, in our case we would have to shift to electricity, which would mean that heat would be provided by heat pumps, for instance, which would then lead to a decrease of the primary energy, but of course the heat pump is still provided by grey power, as we call it, so coming from coal-fired plants or other fossil plants, then it's still not very good, and demand will increase a lot. In that case, the total electric demand for a household, for their home, is decreasing, but again, it's completely electric now, so we need more power to help us out. Also with cars, if we switch to electro engines, which may be 4 times as efficient, it means that it will become all electricity to be produced, and of course, if we don't do it in a sustainable way, then it's still quite a lot. This means that if we shift to an all-electric society, a typical Dutch household, to provide them with the current amenities, it would have to have about 10 megawatt hours, so 10,000 kilowatt hours. And if we don't do it sustainably, it will still mean 23.1 megawatt hours of primary energy, which is, if you look at, and I'll try to point it out, if you look at the original demand, you see that it's 7 times almost more than what the current demand is. So this is a concern, of course, of the government and energy companies. So it's very important to shift to renewables in that sense. Now, if we look at the next slide, I don't think it is doing something. Yeah, okay. It starts with individuals' energy, and well, I'm one individual, so let's look at my own situation, just to be honest. I should tell you, I used to live in Amsterdam. This was my home in Amsterdam. I commuted to Delft when I was working there already, and that means that I shifted from traveling by train to walking or cycling right now. I'm quite close to the university. And my current house, which is not on the image here, but can be seen here to the left-hand side, was constructed in 2004, so it has high energy standards, you could say. But it's twice as big as it used to be, so it's important, of course, to think about energy at all. Then it's all electric already. There's no gas connection, so we have a balanced heat recovery system for ventilation. We have a heat pump system with a whole block, and this preheats warm water, which is additionally heated electrically, which is of course not very efficient, but the heat pump itself of course is. And then we have more electrical devices. So this is my own home. What you don't see is that the floor is actually the roof of a shopping mall. So in that sense, it's quite interesting in an urban context. This was my energy usage when I started, which is, as you can see, 2,000 kilowatt hours more than what an average Dutch household has. But of course, my gas use is 0, but I have to pay for heat from the heat pump system. Now, I took some different measures, LED lighting, energy-saving lighting. I switched some things differently with installations. I added PV on the small roof that you see upstairs. And then I also used curtains because of the big windows that I have. And curtains, of course, as you may know, is easy insulation, which is also flexible. So the energy usage has gone down a lot. As you can see right now, it's gone down to about half of what it used to be. Also, heating demand has gone down, so it saved me a lot of money. Of course, I had to invest in it, but, well, you invest things when you have the money. So in that sense, it's my next investment would actually be like a solar collector or more PV, but which is difficult because I don't have much roof left. I also buy green power, as you can see. So I actually am carbon neutral, but I'm not energy neutral. So this is I'm not fossil free, as you could say. Now also travel is interesting because I used to travel a lot by train, so that has gone down a lot. I used to bike a lot to and from stations. As you can see, it was a factor of 10 more than what I do nowadays, which of course leads to becoming fat. So I have to eat less now since I live in Delft. And there's a camper van I mainly use for holidays. So I don't use as much car than normal people do. But as you can see, if you look at the quantities, we talk about 30 gigajoules as opposed to 1 gigajoule of electric power for trains and 14 megajoule, which I use in terms of food to bike. So in that sense, my total energy demand for traveling is this. Now, an interesting thing, and that's because of the webinars also, flying. Interesting part to look at, because people were asking me, yeah, you talk about your own situation, but you fly a lot for all these conferences. Well, these are the figures for a plane, and it depends, of course, if it's full or not, and if it's flying intercontinental or just in Europe. And if you compare it to a bike, a train, and car, you see that if you use a car not efficient, just by one person, actually flying is not that bad. But of course, the travel distances are much bigger. Now, national travel I do by public transport, so that's not bad. In 2011, I didn't fly so much, so it was very limited, only 3 megawatt hours. That's not really too bad. But 2012, also thanks to the CIB 2012 conference in Sao Paulo, it has gone up considerably. And to give you the comparison, this is more than 5 times the energy I use for my home, and this is 2.7 times all energy I use normally in the Netherlands. So this goes to show that flying and avoiding flying is so important. I could say I only fly for my work and not for private business, private reasons, but then of course we should also take into account offices and so on. So it's a complicated comparison. But to round up this, privately I still need this 17 megawatt hours, which is actually better than the 30 megawatt hours that is average right now in the Netherlands. So I'm going in the right direction, but it's still more than what I'm actually allowed to in the future, the 10 megawatt hours. So energy neutral really is a challenge, and that's why it's one of the important themes of W116 CIB's commission. And also another lesson is, of course, we should hold more webinars and not seminars across the world. Every now and then, of course, you really need to see, to touch, to kiss people, but every now and then it's much better to do these webinars. So I'm very happy with the initiative of CIB. Okay, but that was actually an introduction to the keynote, which will be slightly shorter than scheduled, I hope, which is about cities and energy. City is an intestine, meaning that there's a lot of energy, water, material, and food going into it, and a lot of waste from these flows is produced. And there's a real problem if the city wouldn't be fed anymore. So we should really start to think about this. And why? Because we have occasions already where this happened, especially energy supplies have been halted by various reasons, technical, natural disasters, but also like human interventions, whether it be terrorist or a Russian president. It's all to do with hampering supplies. So also made clear by many people at CIB 2012, we really need to aim for resilient cities. It's the main theme for the coming years, I think. And well, this is a model I will explain while going through it, but we should think about cities as systems where flows are going in and out, and we have to get control over them. And it actually starts with knowing your figures, so you need to know the data. So that's why cities really have to start accounting. And this is a table which you can't see what it actually says, but look at the 13%. This was the start of an island in Denmark called Samsø, who decided to become energy neutral and who started to do the accounting first to understand where the problems lie. Well, after a few years, 7 years to be exact, and with a lot of investments, helped by some funding, but also invested by the people themselves, they came to 99% of self-sufficiency in energy. Actually, they produce more electricity than they need, but they still use some fossil fuels for the cars and mainly for the ferry boats. So that's, but actually right now it's energy neutral, it's carbon neutral, and now they're working on a new project to become fossil free. I think all cities should start to do that. And it's also about understanding the city then, understanding the energy demands and energy potentials. This is a map of Rotterdam, so right in the middle you see Wim Bakens sitting and CIB, and they use more heat than they can actually gain from the sun and from geothermal sources. So we have to do something in the city. And it starts with reducing the energy demand. We have a lot of existing buildings already which are not really energy efficient. This is not a situation, of course, in the Netherlands only. It's across the world. So we have to transform our current buildings into energy neutral ones eventually. Maybe not all monuments will have to look like this. So this wouldn't be allowed, of course. But this is just an occasion of a non-monumentous building that can be refurbished to an energy producing one. So it is possible, and it can be done in a architecturally pleasing way. And there's more examples of old existing buildings that have been transformed into very energy efficient new ones. Not always energy neutral, but much better than what they used to be. And if the new buildings then become energy neutral, we are in the right direction. The second step is to think about reusing waste flows and exchanging heat and cold, or cascading the different temperature levels. We have to understand that the city consists of many various functions of buildings with energy demands that differ dramatically. If you look at these bar schemes next to the images, so this is a hospital, supermarket, office, dwelling, ice skating rink, shop, school and swimming pool, you see that the demand for heat, cold and electricity per square meter is different in every case. So in that sense, it's not very smart to try to improve buildings as separate entities, but to think about exchanging. So start to think about possible exchange of heat and cold and electricity peaks between the different functions. And it can be done, for instance, for heat by smart heat grids that exchange heat between places that have an excess to places where there's a shortage. Then the third step. A city has to interact with the region because they can't produce their own food, they can't produce their own energy completely. So a city needs its environs. It needs more space to get to these amenities. And we could, for instance, think about how to make wastewater and nutrients for areas around the city that could be processed again and made into, for instance, biofuels or food. So wastewater that is actually becoming food or nutrients for plants that get back to the city as food. So there's many opportunities, but the city will really have to collaborate a lot with their environs. For we have to understand that if we don't have fossil fuels anymore, or they become too expensive, we have to solve it on the ground. We can't go into the soil anymore and find these very handy packages. So energy becomes space, and that means that energy becomes one of the struggling factors of how to use space on the ground. And this deals, of course, with the fourth step, which is generate renewable energy. It can be done in the city, but it can also be done in the city region. And I think it should, because electricity needs a lot of space. Well, if you look at normal cities, even this city as Florence, which you see on the background, we had a workshop there, and Florence even understands that they have to become more self-sufficient again. They used to be self-sufficient in the past, in the Middle Ages, and now they are absolutely not. So they think about it, and there's plenty of space, of course, but you wouldn't want to touch upon every monument there. Nevertheless, there's a lot of possibilities, and we hardly use these potentials. So I'm sorry for people with a different religion, but this is just a joke for the Christian ones. Thou shalt produce is what we really have to do, and we have to do it in cities, but also in the surroundings of cities. So I think it's the whole package of all these steps that will be necessary, and I hope that this webinar with the coming presentations will also help to get to these conclusions. And well, thank you for your attention, and I'm looking forward to the presentation by the 3 students later on. Thank you very much.
Thank you, Andy, and my compliments for making statistics interesting. And thanks for the rest of the presentation.
Okay.
I am sharing my screen and going back to my presentation. We will have a start with the first of the three planned student presentations. The presenter will be Dr. Umberto Berardi. Umberto represents the Politecnico di Bari in Italy, although he is at the moment living and working in the US, so it's very early in the morning for him. Welcome, Umberto. Umberto will be talking about how to measure energy sustainability, the possible approaches, the limitations of those approaches, and the trends in doing so. Umberto, if you start with your presentation, we will enjoy it.
Okay, thank you, Will. Thank you for the presentation. Are you actually looking at my screen with my presentation?
Not yet. You have to share your desktop.
Oh. Because, let's see.
Top of the screen, exactly.
I share. I think probably.
Yes, we are looking at your presentation in presentation mode. Go for it.
Okay, thank you, Wim, for the presentation. Thank you, Andy, actually, for the keynote. Well, in my case, good morning to everyone, but probably also good afternoon and good evening to the others worldwide. I'm Umberto Berardi. I graduated, studied the PhD in Polytechnic School of Bari, and nowadays, actually, I'm in Worcester Polytechnic Institute. Not too far from Boston, actually, something like 20 miles from Boston. So here is almost 8 o'clock in the morning. First of all, the outline of the presentation for this morning meeting, I will start with a brief introduction to the energy modeling and to the energy problem of cities worldwide. I will actually move to the energy saving opportunities that we have nowadays for cities, and I will focus on medium-sized and very huge cities. So I will skip from actually small cities in my presentation. The third part of the presentation will be dedicated to a comparison of sustainability assessment systems actually that we have for the city level. And I will consider also the district and neighborhood levels. Then I will move to considering few of the characteristics that certified communities and certified cities have nowadays. And then finally a few trends and actually future steps in the sustainability assessment of cities related with the energy consumption activities. So first of all, I think I don't want to spend too much time about the introduction, but we know the problem. We know that the energy consumption is increasing, and it's increasing not only because the Western and the North America have still actually a huge amount of energy consumed, but also because in the Southeast countries and in developing countries, especially in China and in the South Africa region and in India, we are actually facing on a very huge amount of increasing. And this actually is supposed to become more and more critical in the next 20 years. Together with this, we know that most of the population is moving to cities. We already knew that in Europe, for example, most of 70% of people is living in cities. And unfortunately, from this picture, we can actually have an idea of the relationship between the urbanization level of a country together with the footprint of that country. And we see that actually the more green is the point, actually the bigger is the footprint of that country, which means probably cities are not really the best option in terms of sustainability, at least from an environmental point of view. And as I said, actually, we are moving to a community in the world that is more or less living in cities. In 2008, probably there was the challenge, so the point in which more than half of the people was actually living in the cities, and we know that especially because all the population in developing countries is moving to cities whereas actually has a lot of opportunity in terms of economy, but it's actually creating also a lot of problems in terms of sustainability of those cities. And in principle, it's quite impressive if we consider the energy consumption together with the dimension of the cities, because we are moving from a community in which cities were middle-sized and then became bigger and bigger and bigger, and nowadays we're actually facing with tens of millions in cities. And this is just a projector for the next 15 years, and we can see actually the amount of huge city we will have worldwide. So with this, I actually stop my introduction because I want to move to the main part of my presentation, which is related with the energy opportunity we face in cities, in order to reduce this picture. This picture is showing us, okay, a lot of developing is actually producing a lot of CO2 emission. So in principle, I will start from a very beginning point from the Factor 4 book. It's a book of 15 years ago in which we faced the problem that we have to move our society in a way that we can double the wealth and that'll be a resource. A few years ago, we are actually moving from the Factor 4 to the Factor 10. Let's say, in principle, we have to try to move our cities and our society in a way that we became 10 times more efficient. And I think that is a big opportunity for cities. In principle, I will show you, for example, this very challenge figure that I took from a paper of Carlo Ratti. It just published a few years ago. Carlo Ratti is actually one of my professors here in MIT. He's actually director of the Sensible City Lab. And in principle, he was saying, moving from previous studies, that the energy performance in cities has actually a factor 10 opportunity. Let's say the building itself is able to save at least half, or we'll say probably more, of the energy consumption. But we have to consider the energy saving opportunities with opportunities related with the occupant behavior that can be actually responsible for another factor 2, together with the systems opportunities. So integrating more buildings together, as Andy was saying, in order to share opportunities, together with the fact that the morphology of the cities, so the urban context and the urban shape, can actually have a very huge impact. I want to stress this actually type of figure because I think probably nowadays there is actually huge pressure about building energy, saving efficiency and technologies, but there is not enough pressure on the other sides. We spoke a bit about occupants, and we soon realized a few years ago of the redundant effect. So we save energy in buildings and then people start consuming more energy. But I think what is still missing at the energy simulation, the energy actually speech in cities, is actually an interconnection of the several dimensions. Here you see the energy models that have been used in cities. In principle, we can have energy-based models, economic models, energy environmental models, and morphological models. Each one of these type of energy models for cities is more or less related with the previous dimensions. Let's say an energy-based model is more or less considering the behavior of the people. And an economic actually model is considering the huge possibilities we have at the country level if we're considering the energy policies with actually the possible energy saving. The energy environmental models are more technologically related. They actually are trying to assess the energy consumption and the environmental impact we have in cities. And finally, the morphological models are models that are considering the shape of a city in terms of the relationships between streets, buildings, open space, closed space, in a way that we can influence the shades of buildings together with the ventilation, the wind in buildings, and so on. Now, nowadays, actually, on the column on the right of the screen, you can see a few examples. For example, there is actually a huge amount of energy-based models because we realized that, for example, with Energy Plus or Design Builder Simulation, we don't really know exactly the profile of the energy consumption from people. And I want to tell you and to share with the others that in US nowadays they have actually building energy research benchmark definition, and they are actually using this kind of profile that is quite important because it's giving us the time with a time step of 1 hour the profile for several activities of American people. Obviously, my idea is that this kind of profile can be compared with the behaviors in other actually cities and in other countries. So we know something about the energy-based, but it's still a micro-level model. Let's say we simulate one single building and we study the dynamical consumption of that building, which means we don't really have an idea of the way in which a city is actually working as a whole community. Together with this, the other actually kind of more macroscopic approach to the energy model in cities, let's say the economic and the energy environmental approach, are probably too upscale. They are able to consider the final output of a city, as probably Andy was saying, but they are not able to simulate the behavior of the people. So they don't really pick actually a big opportunity that we have to change the consumption of the people before it's happening. Let's say what people are doing, we have to move people through a more sustainable actually path. So in some way, I think nowadays the real challenge we have as researchers is to try to connect at least these different models, because they don't really communicate each other quite a lot. And the idea, in my idea, is that we have to move from a research point of view, trying simulation models that are able to connect different models, and probably this can happen also outside university. It has to happen outside the academia in order to share these kind of models with all the stakeholders, including policymakers and people worldwide. Just to give you an idea, another actually picture taken from the Sensible City Lab in MIT here, and this is actually the picture of the MIT campus consumption, has just been published on an energy buildings issue, and you can find actually the relationship with the energy consumption of buildings together with the number of people who are populating the different buildings and the kind of actually activities they were doing. These kind of models that are not really common are actually using, for example, in this case, a Wi-Fi network, and we were able to assess the energy consumption of different buildings from the number of people connecting to the Wi-Fi network of MIT. Let's say this kind of models in which we do not considering the energy dynamic without the behavior of the people, without the energy shape of the community, they should be probably be pushed in the near future, because according to me those are actually the challenge. And I want to show you also a good study is actually happening in Bari, in the Polytechnic School of Bari, regarding the urban morphology. In principle, an historical center, so here we are facing on the problem of retrofitting of an historical center has been modeled from an energy point of view, and we were able to discuss energy strategies and energy policy at actually the urban level. And this is still an unpublished work, but in principle the idea is that we have to consider urban morphology together with behavior of people and activities that are happening in the building. And we think, actually, I think really that is quite important to show the opportunities cities are facing in comparison with the energy efficiency together with their smartness. Because especially in Europe nowadays we have actually a huge pressure for the smartness of cities. Every city wants to become a smart city, but we don't really know what is a smart city. So we need to move and probably join the strength and the activities of the smartness movement with the energy efficient movements in a way that can become more sustainable. Now, it's probably not easy to define what a sustainable city is, and I can tell you I faced quite a lot this problem with my colleagues, because in principle, sustainability can be assessed, but it's still an undefined, let's say, concept at the city level. We have to sure be consequent of the identification, predicting, and evaluating of the potential impacts at the city level. So last year I published a paper in which I compared different sustainability assessment systems at building level. Now, if we move to the sustainability assessment at the city level, we discovered that we don't really have this momentum, this actually strength and attention for the city level. In principle, we know we have LEED and the neighbors, we have the BREEAM standard for community, we have the CASHB, now also for cities. But in general, there is actually a poor attention for the sustainability assessment of cities. And this is a pity, because we are lacking actually a momentum in order to consider the energy consumption at a larger scale. Now, what I did actually for this presentation is that I compared the ways that different systems for communities, so BREEAM, CASHB, and LEED for community, are giving to different categories. Let's say I use the criteria and divide the criteria in different categories related with sustainable land, location, transportation, energy, ecology, economy, and well-being, and I look at the total percentage over the total actually assessment. Now, if we look at the energy and resource consumption, it's probably quite easy to realize that the energy attention nowadays cities are receiving in terms of sustainability assessment is quite low. We are actually below the 15%, and that is probably a pity. Together with this, I want to show you probably a useful and quite interesting new sustainability assessment system that has been developed last month. Is the STAR community rating systems. For people who doesn't know it, is actually being developed by the GBC together with the ICLEI, together with other American associations, and it's quite promising in the terms that has been produced as a collaboration worldwide. In principle, if we look at this new sustainability assessment system, we realize that over the 600 points that are possible in the system, or let's say in the 70 under points, if we also consider the innovation part, the climate and energy measures is only actually 100 points. And then if we consider the points within the system, we realize actually the pressure and the attention to the energy actually performance of the cities is not so strong. Let's say the resource efficient use in building is only 15 points over 700. So it's actually few percent points. And this actually allow me to make some conclusion about sustainability rating systems for cities in relationship to the energy consumption of the cities. So for sure, they are characterized nowadays by an unscientific selection of the criteria, and they are characterized by several limits. But I want to share a few definitions that have been recently proposed by Salat from Paris. And in principle, is that actually new sustainability assessment systems are lacking the really energy opportunities we have in cities because they don't really put too much attention to the energy consumption. And probably this is related to the fact that we are not still able to have energy models that are able to simulate actually the behavior of a cities. What I did actually was to compare actually the performance of different communities. So I use a set of 70 different communities, more or less spread around the U.S., and say, okay, let's see the performance as certified communities in order to understand what a sustainable community is actually doing. Let's say, what are the characteristics that we face in a certified lead community. And I don't want to stress on the smart location and neighbor partner and design criteria, but I want to stress probably on the next slide in which I select and I show you the results related with the green construction and technology. Now, if we see this slide, we realize, for example, that over the total amount of possible points, the earned points are very low, which means most of the certified lead communities are not behaving in a good way in terms of the energy-related performance in the categories of green construction and technology. And this is quite important if we consider, for example, the percentage and the relationship, the ratio between the earned points over the total available points for different criteria related with the energy. And we really realize, for example, that if this system is giving 1 point for solar orientation of the community, then the average of the communities have a results of 0.3, which means actually 67% of the communities that have been included in this sample have not an attention to the morphology of the buildings, which is a pity. Now, these two studies still unpublished. I'm actually finalizing. Hopefully, I will be able to submit in 1 or 2 months, and actually we'll be able to show more things actually in the next future. But I want to conclude with few trends in sustainability assessments of cities related with the energy. First of all, we have to face the problem that energy assessment and building level is not enough. So we have to move to a larger scale. We need to do that. But to do that, we have to consider that externalities, behavioral influence, and long-term effects needs new models. We cannot do that with a dynamical, precise model that is able to focus on a very small activity of a guy in a building, together with the fact that we cannot do it at a macroscopic level, just dividing the energy consumption of a city with the number of the citizens, especially because those data are not available, and especially because a city is a much more complex, actually, example. We don't really know who are the citizens, how many they are, if we consider also tourism and other actually opportunities. Then actually I want to conclude this presentation saying you, okay, nowadays multi-criteria system lack or neglect actually energy criteria in a good way, together with the fact that they are not able to integrate the energy consumption with economic and social implication of energy opportunities. So we need to reconnect those actually activity, and I won't actually also be happy if we were able in the near future to balance with the complex of energy consumption models together with the simplicity. Because what we are still lacking is actually an implication for the policies and for the mayors. We need to become actually more familiar to them, and our actually results have to be shared with them. We are actually doing that in the Italian case study I showed you from the Polytechnic School of Bari, because that was actually the final goal of the energy simulation. And I think actually we have to create a momentum in order to press again the energy attention at the city level. And in this idea, probably institutions like ICLEI or other institutions are quite important for us, because most of the agencies for sustainability assessments have actually a real market focus, so they don't really are interested into the city level. But at actually the city level, we have the biggest opportunity in order to go through the factor 10 I just showed you. Well, this is just a brief actually list of reference together with the presentation, and I think I used more or less the 10 minutes I had. So I thank you for the attention, and I'm available for future questions. Thank you.
Thank you very much, Umberto. You're becoming a real professor. You talk about 10 minutes and you use 20, but it was worth it. It's good to see this insight in the different factors of assessment. It's a little bit of a surprise to see how, let's say, energy is of lesser importance than I would have expected.
Well, I think there are several reasons for that. Probably because when we are doing a sustainability assessment, we don't really want to spend days and days doing energy calculation simulations. So most of the sustainability assessors are not familiar with the energy simulation at the city level. I mean, like, it's still an underdeveloped actually topic. We still lack a lot of data about that, so that probably may be a reason. And unfortunately, sustainability assessment systems are too much focused on the way where we can do, which means they don't really put the boundary forward. They don't really push the research and the activities in a better direction. They don't really are focusing on the strong sustainability. They are really focusing on a weak sustainability. Let's say the easiest thing that we can do in order to put a label on a city or on a building, say, okay, this is sustainable.
Okay, thank you for the response. Andy, as an expert in this area and as coordinator of the CIB Commission on Smart and Sustainable Built Environments, would you have a remark or question for Umberto?
Yes, Wim, thank you very much. Well, this goes to show that these assessment models sometimes are not really related to what is really essential or urgent. So I agree that to see that energy has such a low impact, and for instance, the orientation to the sun, which is essential if you want to produce electricity in a city later on. So in that sense, I think in Holland I noticed that most people are shifting away from getting these assessments precise or exactly, even though we also have a BREEAM NL for area development, which is, I think, better than this lead community or neighborhoods development thing. But my question would be, Umberto, I thought it was quite interesting if you look at these factors that would improve, or which are the potential of improvement of buildings, the occupants participation, the system improvements, the building design improvements, and then the urban factor was still open. And I think that's also one of the challenges for you and other students here, to think about what type of a factor improvement could we establish on the urban scale. Do you have an idea?
Let's say in terms of simulation?
Well, not simulation.
Simulation result, like, or just a theoretical idea? I think actually we have to focus this kind of answer to the kind of communities, because the urban texture are very different, and we are considering the New York City map against, let's say, a Rotterdam map or a very small city in the south of Italy. So in principle, we are still lacking probably the urban morphology factor related with different shape of the city, which means actually there is no probably study at the moment that is looking to the urban morphology and energy implication with different patterns. So I probably agree with the factor too.
We have. If I can interrupt, because in a couple of years ago, I did my PhD myself, so I looked at morphology effects of urban geometry in cities, and there's been more studies in Europe, I think, on urban patterns and the influence on energy consumption, even in the 1990s already.
Yeah, I know.
But I think these should really have an update. So I agree with you. There should be more research with the current insights.
I don't know. I know there were few studies in the 90s and in other cities, but I think probably those studies were not really focused on integrating the morphology of the building together with the behavior of the people and the system opportunities. Oh. So in principle, they were really focused on the morphology of the city. So nowadays we don't really have systems and models that are joined the different dimensions. And together with the fact that probably we don't really are able, or at least we are not still on the point to be able to study the morphology of the city in terms of, let's say, natural ventilation and CFD simulation of different patterns. So they were more geometrical studies most of the time.
And Andy, may I, for the sake of a little bit of timekeeping, intervene?
Sure. Yeah.
I think
I also wanted to say I agree, so let's go on.
But also the need for bringing together already available knowledge.
Yeah.
And maybe in conjunction with that, there's the need for some next generation fundamental thinking on assessment issues.
Yes.
If you allow me, I will go to the next presentation, which is by Electra Columpi.
Yes.
From the Utrecht University here in the Netherlands. Electra will be talking also about measurement of energy sustainability of urban communities. But she'll do a comparison analysis of 4 sustainable assessment tools for urban areas. Electra, the floor is yours.
Yeah, that's correct. Can you see now my desktop, Wim?
We can. Excellent.
Yeah, okay. Well, thank you for inviting me to present my master's thesis project on measuring energy sustainability of urban communities. And I'm glad to see the big link, the great link there is with also the studies of Umberto. It is indeed a comparison analysis of 4 recently developed sustainability assessment tools for urban areas. Well, as it has already been stated, you all know that we live in an urban world, and since 2008, more than half of world's population live in urban settlements. And that has, of course, a great impact to the energy consumption and the CO2 emissions of the cities. It is not too much to say, then, that the battle for sustainable development will be lost or won in the cities. Recognizing this fact, more and more urban communities embark on the journey to drastically reduce their CO2 emissions and become carbon neutral. How can we monitor, though, the progress of these urban areas and measure the level of energy sustainability they have achieved? Well, the realization that measuring only the performance of single buildings is not enough anymore has led recently to the development of assessment tools that measure the broader context of urban environment, which means districts, neighborhoods, and urban communities in general. These tools are designed to evaluate if the development or redevelopment plans for an area meet certain high levels of sustainability. Their function is actually to work as a communication framework between designers and decision makers, namely a framework that would facilitate dialogue between the relevant stakeholders in formulating and pursuing a sustainable design project. Owing to the fact that these tools have been launched recently, as I said, the number of scientific articles until so far examining their methods and their effectiveness is limited. For this reason, as a result, I focused my study on the analysis and comparison of 4 of these tools. I chose 2 of the most prevailing and internationally applied tools, the English BREEAM Communities and the American Lead for Neighborhood Development. And I also chose 2 Dutch tools, the Dutch BREEAM, BREEAM Gebiedsontwikkeling, and Het Aarstedt en Bouw, that is used currently from different Dutch municipalities, because the case study area I examined was in the Netherlands. These tools measure different themes of urban sustainability, but I was focused particularly only on how do they measure energy. And more specifically, I was wondering how is energy sustainability assessed by the 4 assessment tools for urban communities in theory and in practice. As a result, my methodology was divided in 2 clear parts. The first part was the theoretical analysis of the tool, a comparison analysis based on the literature, and the second part was a case study to examine how do these tools function under real-life conditions. For the first part, the theoretical analysis of the tools, I started first with studying different examples of eco-cities with exemplary energy performance. And I also reviewed the literature on the principles of energy-efficient urban areas. From these 2, I came with some prerequisite criteria for urban energy efficiency. In the same time, I studied urban sustainability assessments like city awards and city rankings existing in the literature. And from them, I collected energy indicators that already exist in order to measure energy in urban areas. From the prerequisite criteria and the indicators that exist, I created a comprehensive list of energy indicators measuring urban energy efficiency. And I used this list in order to filter the tools and test whether they include these criteria and these indicators. The list I created included 21 quantitative energy indicators within these themes. And I set 3 indicators as key indicators: energy consumption of the area, CO2 emissions, and the renewable energy use of the area. Because these indicators have the potential to give a complete overview of the energy performance of the area. Here you already see the results of the comparison of the tools with this list I created. The names around the spider diagrams are the themes of the comprehensive list. The ones with red color are the key indicators. And you can see which of these indicators the tools included, which of these themes, and which not. There are, for example, important key indicators like energy consumption that was not included in the tools. And you can also see that Het Aarstedt and Bouw had the biggest overlap, the similar themes with the list, and they included also the 3 main key indicators. This is a general overview of the results of the comparison and shows how the percentage of compatibility of the tools with the list. In general, as you can see, the percentages are quite low, and there were 2 main reasons for that. The first was that the tools neglected some of the themes and indicators of the criteria included in the list. And the second and most important is that the tools used the indicators measuring the relative improvement of the area in time. For example, the tools used indicators measuring how much has the energy consumption of the area been reduced after the development of the plan, whether it has been reduced by 20%, 30%, while the list included indicators measuring the actual performance of the area, giving information about, for example, the energy use in megajoule per capita or per square meter, and the actual CO2 emissions. The Dutch tool Heppersted and Bouw was the most compatible with the indicators of the list, since its methodology is more focused on providing information about the energy performance and the CO2 emissions before and after the development of a plan. This is another comparison of the tools. It is not anymore a comparison with a generic list. It's a comparison of the tools with each other, and is based on the value that the tools reward on different themes, depending on how much points do the tools award an area for fulfilling a criterion. You can see from these diagrams that the tools BREEAM communities and lead for neighborhood development give primary focus, which means they reward more points to an area if the area includes sustainable certified buildings than if, for example, it incorporates renewable energy, or if it has if it has improved energy efficiency. You may see that the tool BREEAM and Nelhebits and Vikelink has a more holistic approach and is actually distributing the points and the value more in the same way between the different things, which is the different themes, which is something preferable. The second part of the analysis of the tools was the practical application of the tools to a case study area. As I mentioned, the case study was chosen Lijnbaan area, the central quarter of the city of Rotterdam, which is currently under redevelopment. The tools were applied in order to assess these redevelopment plans. Here you can already see the results, the scores that the plans of the area achieved by each of the tools. And this is a table that shows you how we came to the scores and how the application procedure happened, which indicators were included or not, just to have an idea. In general, as an overview, you can see that the plans of Lijnbaan area did not score significantly low in the energy indicators of the tools. More specifically, for the tools BREEAM communities and lead for neighborhood development, the area achieved 0 points for the energy performance. And that was because these tools, in order to reward any points to the area, asked as a prerequisite criterion the existence of LEED or BREEAM certified buildings in the area. Since there were no certified buildings, the criterion could not be fulfilled, and the area could not achieve any score for its energy performance. And here I'm resuming the main findings that revealed from the practical application of the tools. Firstly, it was noticed that the prerequisite criteria of about certified buildings that the tools BREEAM communities and lead for neighborhood development include cannot be easily fulfilled by regular areas, as for example it happened in the case of Lijnbaan. These criteria can be very limited, and they might exclude otherwise sustainable areas from being certified, considering the fact that there are not so many BREEAM or LEED certified buildings around the world. Second important finding that it appeared from the practice is that the tools BREEAM and LEED have limitations to certified redevelopment plans of existing areas, because some of their criteria have too high requirements. Their methods work best actually for newly built areas, or when at least 50% of the total floor area consists of new buildings. Finally, it became clear that the application procedure of the tools was a highly demanding process, since it required an excessive amount of energy data that sometimes was difficult to cover, and assumptions had to be made. Considering all the above, one might question whether these tools could assist the local authorities in evaluating their plans and could improve actually the the planning procedure of municipalities. And I would like here to make a summary of the main conclusions of the whole study. Well, these tools, these assessment tools, can indeed be useful for the designers to improve the efficiency and sustainability of their plans. However, by studying their methods more in detail, I realized that these tools are solely confined to measuring the relative improvement of an area, its progress during time. With respect, though, to the actual energy use and actual CO2 emissions, these tools give no quantitative evidence that a project that has been highly rated will emit less carbon than a lower rated project. As a result, these tools cannot be used to compare the performance between different areas. And let me present an example on this point. Let's assume that a neighborhood in US has improved its energy performance by 30% and has achieved a LEED Gold certification, while a neighborhood in Europe has improved its energy performance by 10% and has achieved a LEED Bronze certification. However, even if we have these titles, we still cannot know whether the total energy consumption of the area in US is lower than the energy used in the area in Europe. And this is how we can have misleading results, and how the rankings can bring misleading results. Another important conclusion about the tools was that they actually give more emphasis to sustainable certified buildings than to other parameters of energy sustainability, such as, for example, the energy efficiency of the area or the share of renewable energy production within the area. It seems like the tools still have the tendency to assume that the area is an aggregation of single buildings, and if all the buildings are sustainable and certified, then the whole area will also be sustainable. However, in that way, they miss the important interdependencies and synergies that exist in sustainable urban areas, in sustainable urban design. And to this point, I would like to bring another example. Let's assume that on the neighborhood you can see on the picture, a new certified building is added. Even if the building has an excellent energy performance, the final outcome is not sustainable anymore, since this building does not let the house in the back to take advantage of the solar gains. This example wants to show that even if all the buildings in the area are sustainably certified, this doesn't imply that the final area will also be sustainable. And I would like to close my presentation with some recommendations for an improved assessment tool and for a comprehensive methodology for measuring energy in urban areas. What I realized and what I understood from all the study is that it's very important, it is essential to have a common measuring language for urban energy efficiency. Meaning we need a common language between all the relevant stakeholders and the academics developing models, the international institutions developing assessment systems, but also the local authorities implementing these tools. More specifically, with regards to the assessment tools, it is important to always include quantitative indicators measuring the energy consumption and the CO2 emissions of the area per square meter floor area. An improved tool should actually be able to provide information about the energy performance of the area before and after the implementation of a plan. To achieve this, the tool should use actual data about energy consumption in the area before the plan, and should also provide estimations about the energy consumption after the plan, based on the added floor area, square meters of new or renovated buildings and their energy performance characteristics. In that way, an assessment tool can measure and rate both the progress of the area in time, but also compare its energy performance with other areas. That was my presentation. Thank you very much. I'm open for questions and for discussion, since also the other people are very relevant to the topic.
Thank you very much, Electra. Excellent presentation. You make it very clear that you simply pick a tool, but you should think about the impact of whatever tool. If I can be made presenter, Tom. Thank you very much. Then I would like to introduce our next speaker. But first, Andy, do you have one or two short questions to Electra, focusing on this presentation on assessing tools and comparison, assessing the assessing tools? Andy?
Well, thank you, Wim. I will keep it very shortly because I think we're running out of time.
We are.
I would just like to commend, and maybe that's a question that Electra can approve of, is that we should be careful also with using different criteria for energy which actually overlap with one another. If you talk about energy consumption and CO2 emissions and renewable energy, then energy consumption can be filled in by fossils or by renewables, and fossils produce CO2 and renewables hardly any. So I wonder if the emission of CO2 as a sole criterion wouldn't be sufficient, so that not all tools have to mention them all. I'm here in favor of clarity and just using one indicator when possible. Do you agree or not?
Yeah, I would definitely also agree on that. I would also try to make it as minimum as possible. The difference is that it's good to have one key indicator, like for example CO2 emissions, as you explained, and then under this indicator have other secondary indicators explaining why this indicator, the results of the main one. So then we can also understand why the CO2 emissions are high, because we have this percentage of renewable energy, or because we have, so then we can put them in the right order and priority.
Okay.
Thank you very much, Electra.
Thank you.
Thank you very much, Andy. Yes, we are running a bit out of time, so I'm beginning to pressure a little bit.
Okay.
If you allow me, we are going to the last presentation. That is to be provided by Nico Tilly. Nico is also of the Delft University of Technology in the Netherlands. He, as I understand it, will not focus on assessment models, but on fossil-free livable cities. Nico, if you're the presenter, you can share your desktop and provide your presentation, and we can enjoy all of that. Go for it.
Mm-hmm.
Share your desktop. Thank you.
Yeah, is it on? Okay. Okay, thank you very much. Welcome everybody. Yes, my presentation is about livable fossil energy-free cities, and I focus a bit on Rotterdam energy project planning, what we have been working on the past few years. But to start with the livability part, livability has a lot to do with social capacity and also the costs of energy. And if we look at the energy costs of rental homes in the Netherlands, for instance, but in the rest of the Western world, it's not much different. We see actually over here that this is these are houses from the 70s, and they actually pay more energy to their energy bill than they have to pay to rent. So this is very important to notice, that there are some people who, well, it really matters to that they have a lower energy bill, so-called energy poverty. But it's not just for rental homes. Here we have also graphs for people who spend energy and in relation to their mortgage, what they spend on energy. And what you see is that in 8 years' time, from 2000 to 2008, this has doubled, and the expectations are that it will even rise faster than this. So energy is not apart from the CO2 issue, it's also very much an economic and a social, well, actually livability issue. Well, here we have used GIS mapping. We are starting to use GIS mapping a lot in our studies right now. And this is a map of the energy use per neighborhood in Rotterdam. And here below is a map on the income of people in the same city. And when we combine these, we see that in certain areas, the light green areas, people already pay 18 to 19% of their income to energy. And one of the papers I studied mentioned that at 20%, you really talk about energy poverty. But I mean, 18 to 19% in this quantity in a city like Rotterdam is so much that we really take action on this. So this has been quite important to get this on the agenda. And of course, there are solutions which we can take, like smart meters, insulations, lower rent, green loans, and have actually lower rents for these people, and also a lower energy bill. Of course, we want to scale up energy. We have started with energy in buildings and energy positive buildings in the late 90s in Freiburg, and now we go to neighborhood level and to urban level. So actually, to do this, we followed the structure which was presented by Professor Andy van der Dobbelstein in the city, and we studied the reduction of demand. So we looked at each household or neighborhood typology, houses from the 30s, from the 80s, from the 90s, and we knew which kind of energy households they have and what the reduction of these household typologies are. Of course, we always want to have more precise data, but this was a roughly guess, a best educated guess. And then we also knew the quick wins in the buildings from the 60s, 70s, and 80s, so where we had to start for these neighborhoods. Another step was actually to go and look at the exchange of energy waste flows, where we have, for instance, here a standard building from a certain era, to insulate it and then have a reduction of energy demand, and then reuse its waste flows like hot air which is leaving the building by taking the heat out of hot water. But looking at this, which was an interesting study by Andy, we said, well, if we have this, why don't we scale this up? Why can't we use the same trick, what we do within the building, between buildings? So look at different programs in the city, and then when we've done that at neighborhood level, we can also exchange between neighborhoods or between districts so that we can actually scale it up and make energy part of planning, because there's a huge gap between energy and planning. One of the things we looked at was, for instance, that a supermarket, 1 square meter of supermarket has enough waste heat to heat 1 square meter of apartment. Or the ice skating rink swimming pool example, which has already been given, is a ratio of 1 to 3. But also the greenhouses, which I think is very interesting for future city development. A greenhouse on top of the roof can count for 1 square meter of greenhouse, has enough heat production in summer to heat an apartment of 4 square meters. So you can have 4-layer apartments with 1 greenhouse on top of it. That is with seasonal storage, of course, because you have to store the heating which is produced in summer and use it in winter, for instance, with heat-cold storage or huge boiler systems. So if we look at what has been done so far, is that we usually went to the building level, right here down below, then reuse waste flows, then use renewable production, and then clean, efficient fossil energy. But with this system, with scaling it up, we can have actually different routes and actually first reuse the heat waste flows at neighborhood, district, and then city level. And then the last step would be renewable production, so that we completely fully use the waste flows which are existing in the city. So if we do this next step, this exchange of waste flows in the city of Rotterdam in this case, we have been looking at the district heating network. There is a potential of 2,000 megawatts, which would be enough for 1 million households. But of course, this energy is derived from fossil-based waste flows. So what if these waste flows get less? So we have been thinking of replacing these fossil-based waste flows, which is hot water in this case, by feeding it with geothermal energy, so that if there is a district heating network that is actually just hot pipes very well insulated in the soil, we can replace the feed-in of this with geothermal energy. So how the system now works is actually that we have a power plant, for instance, or where there's a lot of waste heat. They produce electricity, and well, heat is just wasted. And then the hot water goes to the homes. Usually they are new buildings because these are the ones they can connect easily, but they don't need that much energy anymore because they are well insulated already. And then the cold water goes back to the industry where it's used again for cooling. But if the water is not cold enough, the industry or the power plant can't do much with it. So what we try to do is actually make a smart grid for heating and cooling, so that we have the waste heat transport not just one way, but that the hot and cold water can be fed with different people consuming it and producing it, and also connecting not only new homes but also old homes, which much more needed. So this is a next step, and that's the REAP2 study we also did in Delft with DWA and Dubbel Strijkers architects, where we, for instance, looked at being the district heating network which is existing, and then cascade it down. I will show an example of that in a moment. But also have, for instance, in this area, we have a medium temperature island where you have exchange between supermarkets or greenhouses and apartments. So it will actually be a mix of a central network, a local network, and some autarkic units which are fully providing themselves. So if we look at this figure which was drawn, is that, for instance, this is the 19 degrees Celsius heating network which goes into a building or a whole neighborhood. Then 17 degrees Celsius water comes out, goes into this neighborhood, goes to 50 degrees, 30 degrees. So this is the cascading principle, actually reusing this heat. When we exchange between, for instance, a supermarket and an apartment, it's quite possible that the supermarket only can provide 35 degrees Celsius of hot water. But if this building needs more, this needs more hot water than the 35 degrees being sent from the supermarket, then we can have a heat pump installed here and actually upgrade the heat left over from this system. So it can be much smarter than we have been doing so far. In this study, so we came up for the district heating for existing buildings is to cascade it, to exchange it, what I just explained, and to have self-sufficient, and then it was worked out in different typologies. So we had now reduction of demand, exchange of waste flows, and then there's this, of course, the renewable production with these energy potential maps, mapping, which has been done a few times with colleagues from University of Delft and even Dobbelsteen. And in Rotterdam, we tried to do this for also the Lijnbaan area, and we looked actually at the solar potentials at the roofs, but we also combined the data we had there with the housing owners, with people who already started putting solar PV on their roofs, so that we had people already active in this field to use them in consultation rounds, etc. So we're now trying to scale it up and put it in a process, to make things happen. Energy scenarios for existing neighborhoods, that would be a next step, because at neighborhood level we noticed that many people are active. And if we look at the transition we are expecting from these two studies we did, it's kind of patchwork between central and decentral. Electricity, which is fed by solar, wind, geothermal, biomass, and others. And heating, especially district heating, heat cascading, low and medium temperature networks, autarkic blocks, also biomass, wind, and the rest of the renewables which are in place. And actually, to plan for this is very difficult. So what we have been doing so far is put data of the whole city of Rotterdam, of the primary energy for industry, residential, services, traffic, and energy production. And here you see actually the primary energy carriers being fed into the system, and we can actually play with this. This is a tool which is developed by Sebastian Carney. We can play with it, and we can actually see the change in CO2 emissions directly. So we don't have to calculate for weeks and weeks. We can use it in stakeholder environments where we, together with the stakeholders, define what the new energy mix can look like. But there's one problem so far. We have this. It's done this is an example from Glasgow, but we've done this. It's been done for 15 other cities, but it's on a city and regional level. So what we try to do now is actually bring it back to neighborhood level. So again, we need the reduction potentials to feed in the figures for efficiency. We need the exchange levels and where do we want to bring the district heating. For instance, area with a high floor space index, areas near to the existing district heating network. So this, we notice that there will be a patchwork of different solutions in the city. And this also adds to the resilience in energy. If we only have one big energy system, when it fails, the power system fails, everything is down. But having this patchwork of different productions and use makes it much more resilient when there is a failure at a certain place. So this is the next steps we are going to take in the next 2 months. And with that, I would like to conclude my presentation. Thank you very much.
Thank you for that. And as an engineer, I do recognize a lot of your things you're saying. Andy, would you have one short question for Nico?
Thank you. Can you hear me?
Yes.
Oh, yeah. I was inserted a bit late. Yeah, thank you very much, Wim. I have one small, short question for Nico. Knowing the situation in Rotterdam, how is the city going to deal with the heat grid company who actually prefers to have all buildings connected to their high temperature system, including new developments? How are you going to deal with that?
Yes. It has indeed been a very a break on developments because they want to connect all buildings to them. But we are actually proposing a shift that the session areas where there is a duty to connect to district heating and not first look to make these session areas smaller, because so far the energy companies have not been able to connect all buildings, and that is they can only connect the buildings which are close to the district heating network. So we are proposing a shift to only look at these areas where it's a good business case and where it's energy efficient, and leave the rest of the areas as it is, except when new infrastructure is planned. So this shift is happening, but yes, it has been a huge break on new developments. Yeah.
Okay, thank you very much, Nico. It's good to see that this is not just an academic research, but it is having its impact on city development in Rotterdam. We go, if you allow me, to the last part of this webinar, the question and answer session moderated by Laura. Laura, did you receive some interesting questions for maybe one or two of our presenters?
Yes, I did. I think due to time I would like to stick to one question for each.
Okay.
Then I would like to start with a question for Andy van der Dobbelsteen. The question is, would there be a simple tool available to measure my own energy consumption and to see the biggest and simplest opportunities for this reduction?
Thank you, Laura. Am I on the line?
Yes.
Yes, I am. Okay, thanks very much. Well, that's a good question, of course. Also because there's recent developments in that direction. Well, there is simple tools to, of course, measure your own energy consumption. That's the meter in your own home. And there's easier devices nowadays that you can even see it very clearly and get it connected to your mobile phone through apps. So that's also possible. So I think everyone should be able to really keep track of their energy consumption. Now, where to see where the biggest opportunities lie, that's a part of a consulting job, partly. But you can, of course, derive it a little bit from your own consumption of gas on the one hand side or electricity on the other, or perhaps in different countries also other fuels, and see what that is used for. In our regions of Western Europe, commonly most gas is used for heating purposes, meaning heating the house, and then second is heating hot water. And electricity mainly goes to using lighting systems and equipment, televisions, kitchens, and so on. So these are things you have to look at, and it's a bit of a trial and error at the moment. But there's also devices that you can put between the plugs and the sockets of your electricity supply, and then you can see what each apparatus actually uses. I can imagine that not everyone can buy enough of these to see everything, but it's a bit of a trial and error. So start to look at the power of your equipment, so that you have an estimate of how much electricity they use, and what you use for heating you can really see by the gas meter.
Okay, thank you, Andy. Yes, I think especially the more easy solutions like buying something that registers your energy use and then coupling to it to an app, for example, for your phone, would be really useful for people to make it more accessible. Okay, then a question for Umberto Berardi. This is a question by Ridwan Yunus from Australia. His question is the level of awareness among the building's occupants in preserving the usage of energy and resources. Do they really care, or do they want to reduce energy and resource consumption? Could you?
Is this the question?
Yes. Well, it's about the level of awareness among the building's occupants in preserving the usage of energy and resources. And the question is, do they really care, or do they really want to reduce energy and resource consumption?
Okay.
So what's their level of awareness?
Yeah, good question. Actually, I'm not the aspect of awareness and people behavior and changing the people behaviors related with the energies, but in principle, according to the literature, so this is not the outcome of my results. I think that we don't want even to divide the two goals. I mean, like if people care from a political culture, or they care about economical consequence, I think we are actually still on the same path. So in some way we have to use both the idea behind actually the sustainability movement in order to push change in the behaviors. I can tell you in my own experience with the case of South Italy in Bari, it was mostly related with the economical consequence, and was actually related with the fact that most of the buildings are public administrated. So in some way, the mayor wanted to reduce the bill at the end of the month. But even if you do that from a political point of view approach, and you want to reduce the energy consumption because you care of the environment, I think still is a good idea. What in US is always probably related with the energy cost. So, but obviously it depends also from the cost of electricity. So in Italy it's much higher, and the attention for the economical consequence of energy saving is higher than it is in US. So it's probably not easy to answer to this question, but I will tell to the answer that the probably good answer is both. Both one and the other.
Yeah, I think that's interesting what you say, that it's also depending on where you do this.
Well, the price and the cost is different. Even the availability. Yeah. If you are in a country in which you don't really have electricity, obviously the approach to the energy saving is different, because you are going to a society in which you can have a lack of energy. So it's going to be a different actually perspective from a political point of view, both environmental and both economical.
Okay, very clear. Thank you for your answer. Then I have a question for Electra Columbi. for you, the question is, are there assessment tools in which the assessor can give his own way to topic? So not to evaluate one area, but to compare, not to compare areas, but to evaluate one area.
Yes. Did you ask me if there are assessment tools where the assessor can put weightings? This is what you said.
Yeah. So you have a sort of your own adjustments to the assessment tool.
Like an outside influence, like the people could put the weightings into what we weight, because this is different, the question. Not yet, but I think that the research community is exactly now at this level, at this point, that they are trying to incorporate and to make more interactive assessment tools, that the communities themselves have the opportunity to participate and to put their opinion about their assessment and actually put the weightings about what should be assessed. If this is what you were asking me, this is what I think.
Yeah, I think that's the answer you're looking for. Well, thank you for that.
Thank you.
And then we go to the last question for Nico. As scientists, we probably can all understand the exchange of heat between functions. But do you feel that also local decision makers can make this distinction, and do they really understand the process? And are they willing to plan according to this exchange of heat?
Yes, a good question. It's let's say it's difficult for local decision makers to see the exchange between program, for instance, a supermarket and the building. There's a lot of complicated things going on between parties who have to agree on delivering or not. So that is where this backup system comes in, like the district heating magnet. So to give the short answer, yes, they agree completely on having district heating on city level. Of course, on the building level, within the building, it's already existing. But the scales in between, so neighborhood level and district level, it's very difficult because they also have to invest in it. So what you see happening is that on cluster level, if you have a building, which is one big building with a few functions in it, then it will work already now, because that's a scale up, first upscaling from the building level. But on higher scales, it's still study and trial and error and pilot areas. So there's still a lot of work to be done there. Yeah. So yes, it depends on the scale. Yeah.
But are these pilot studies already in action, or is it just a plan?
Yes, there's one pilot area in het Merwe-Vierhavengebied in Rotterdam. I don't know the status of that, but there's also will be a nice European project called Celsius Cities, in which 5 cities in Europe participate, and there we have 2 or 3 pilot areas. One on the level of where we have a building, that's called the Rotterdam, where we have a lot of different program and functions inside. Another one is a sewage plant, which the waste heat and the biogas for other areas. And there's another area of Mineba where they are actually steaming cereals and stuff like that. And they have a lot of waste heat as well. So it's one step up from the building or cluster level. We try to get there. Yeah.
Okay, and the waste heat, where it's used for the city district heating, or is it directed to a certain area directly?
Yeah, well, it's as close as possible, so it shouldn't be transported too far. The district level on city heating is, of course, transported a lot, but if the waste heat is in the factory, then we try to use it in the same area. Yeah. Okay.
Yeah. Well, very clear. Nice to hear some examples also. Well, then I would like to close the question and answer session. We are 10 minutes out of time. But well, back to you, Wim.
Thank you, Laura. And yes, before closing this webinar, a couple of remarks. To the attendees especially, know that it is still possible to ask more questions to the presenters. Simply write an email to the CIB Secretariat and we will forward that and oversee that you will receive an answer. Know that we have recorded this webinar, the webinar as a whole, and also the standalone presentations, and we will make them available. You will receive notice in due course as quickly as possible. If you want more information on CIB webinars, on regular conferences, on often free downloadable publications, subscribe to the CIB monthly newsletter. It's free, and if you want help, again, ask the CIB Secretariat and we will guide you to the process. Before my last announcement, a couple of things. I want to thank Tom for his technical support to this and an earlier webinar. I want to thank Andy for a very well done CIB introduction and keynote speech. I want to thank our 3 student presenters, Umberto, Electra and Nico. Very well done, stimulating. I hope you will receive more responses, and I hope it will be the basis for more exchange with students who are doing similar work. I especially want to thank Laura. You have done a great job in moderating the question and answer session. And you have done a great job in organizing all of this. This is the last time, Laura, that we will see you in one of these webinars in this series, because you're going very soon on maternity leave. I wish you all the best for the coming months. We'll see you back after the series is done.
Yes, thank you very much, Wim.
Ladies and gentlemen, do know that the next webinar in this series of 4 will be on resource issues. That will be 1 week from now, December the 12th, same time. And then we have a last one on measuring urban sustainability. Very much in line with the 2 presentations we had today, but focusing on sustainability in general and the trends in assessment systems. Interesting for both Umberto and Electra, and what they have to say should be interesting to the presenters then. I thank you all very much. I hope to see you again 1 week from now in our next webinar on resource issues, and I herewith close the webinar.